Separable 3D reconstruction of two interacting objects from multiple views. We want to reconstruct individual geometries from human-human, human-object, hand-object, object-object interaction scenes along with their texture from multiple RGB views. In all interaction scenarios, we use only multi-view RGB images along with segmentation masks as input. But this is a challenging task because of different scales of the objects and the heavy occlusion involved. A naive solution would be to reconstruct individual objects in isolation using their respective segmentation masks, but this leads to severe artifacts because of occlusion. Another approach in the case of a known object template would be to fit the template to image observations by optimizing for 6 degrees of freedom using differential rendering with silhouette loss. While this works reasonably well for unoccluded objects, we get incorrect poses in the presence of occlusion. So we present a method to reconstruct segmented objects, using calibrated multiview images taking the human-object interaction as the example. We reconstruct the human and object separately as two signed distance fields. Union of these two signed distance fields gives the overall scene signed distance field. Since we also learn the associated radiance field, we can also render novel views separately. We achieve this separable reconstruction by first encoding the position using a multi-resolution hash grid and obtaining a geometry feature vector that is shared for both MLPs parametrizing the two signed distance fields. Using the individual signed distance fields, we obtain the scene signed distance field by simply taking minimum of them. Then we derive the human, object and scene opacities using the previously obtained signed distance fields. The scene signed distance, along with the position, viewing direction, normal and a geometry feature vector are fed to another MLP to obtain the scene color at each position. The obtained opacities and color are then used in volume rendering. We consider the scene opacity as alpha composite of human and object opacity. Thus we can separate the color terms for human and object and use them for rendering loss. Since we only consider opaque objects, the product of human and object opacities at every point in space should be 0. So, we use this as a regularizer. Please refer to paper for more details. This shows the full architecture of our method. Next, we will present some of our experimental results. First, we show a comparison of geometry reconstruction and novel view results. Here we depict a few human-human interaction scenes. Observe how our method outputs better results near the contact areas. Next we present scenes from human-object interaction. Notice the additional gap between hand and book and object SDF++ results, compared to ours. Next we present scenes from hand-object interaction data. And few scenes for two static objects. Here we show a comparison on reconstruction between our method and segmented news 2. Next we show color renderings and normal renderings for the overall scene as individual objects that are obtained using our method. By using the predicted sign distance fields, we can determine the distance of human and object with respect to the other, hence obtaining contact maps. Thank you for watching.